The tangent line of a function f of x at x is equal to a can give you an approximate value of the function for points close to x is equal to a. So if you draw a tangent line, so this is a graph that's concave up, like an upward U-shaped curve. And if we draw a tangent line here, you see the tangent line here is all below the curve. Because when a function's concave up, the tangent line's below, therefore you would have an underestimate. Because if we take values on this tangent line to estimate points for f of x, these are all below the curve, underestimates. Vice versa, if we have a concave down function, upside down U shape, and we draw a tangent line, we are going to get overestimates because the tangent line is going to be above the function when the function here is concave down. So let's do an example problem. F is concave up on its domain and f of 4 is equal to 5 and f prime of 4 is equal to 3. So what is the estimate for f of 3.8 using the local linear approximation for f at x is equal to 4? So what we want to do is use this information to get the equation of the tangent line. So y minus 5 is equal to 3 times parentheses x minus 4. And now we want to plug in the 3.8 because we want to approximate using the tangent line. So it's y minus 5 is equal to 3 times 3.8 minus 4. And then if you simplify this out a bit, so y minus 5 is equal to 3 times negative 0.2. And then 3 times negative 0.2 is negative 0.6 plus 5. And then we get y is equal to 4.4. Alternatively, it might be easier if you just rewrite this function here. So if you do the 3x, so if you do y minus 5 is equal to 3x minus 12, and just do y is equal to 3x, add 5 on both sides, minus 7. This could be easier for you to just do, because you can just plug in 3.8 here. 3 times 3.8 minus 7, you get 4.4. So that's the estimate for f of 3.8 using the local linear approximation for f at x is equal to 4. Is it an underestimate or overestimate? Because this is concave up, so the tangent line is below. So underestimate because f of x is concave up. So the function f of x equals 5x minus 2x cubed minus 2 is concave down at x is equal to 1. Find the tangent line of f at x is equal to 1. So you see in question 1 they gave you like the x1, y1, and like the derivative. Here they don't tell you anything. You have to figure it all yourself. So let's see what f of 1 is equal to, and that'll get us our y1 value. F of 1 is equal to 5 times 1, which is 5, minus 2, because 1 cubed is 1, times 2 is 2, and then minus 2. So f of 1 is just equal to 1, because 5 minus 2 is positive 1. Let's find f prime of x. So f prime of x is equal to 5 minus 6x squared. Therefore, f prime of 1 is just going to be 5 minus 6, which is negative 1. Now we can write the equation of the tangent line. Y minus 1 is equal to negative 1 times parentheses x minus 1. That's your equation of the tangent line. So what's the estimate for f of 1.1 using the local linear approximation? You just plug in 1.1. Y minus 1 is equal to negative 1 times 1.1 minus 1. That gets us over here. Y minus 1 is equal to, well, negative 1 times 0.1 is negative 0.1. And then that gets us a y, you add 1 on both sides, y is equal to 0.9. Because they tell us the function here is concave down, the graph is going to look something like this, and any tangent line is going to be above the curve. Sorry about that bad drawing. So therefore, this is an overestimate because f of x is concave down. So consider the differential equation dy dx is equal to e to the y times parentheses 2x squared minus 5x. Let y equals f of x be the particular solution to the differential equation with the initial condition to f of 2 is equal to 0. Write an equation for the line tangent to the graph of f at the point 2 comma 0. So 2 is your x1, 0 is your y1. And we have to find what's the derivative when x is equal to 2. So what's f prime of 2? So f prime of 2 is, well, you see this is the derivative function. This is your y prime. It's just dy dx. So you see e to the y. Well, when x is 2, y is 0. So it's e to the 0. You're plugging in the 2's for x, 0's for y. So 2 times 2 squared minus 5 times 2. That gets you, well, e to this, anything to the 0 power is just 1. Parentheses 2 times 2 squared is 8 minus 10. So f prime of 2 is negative 2. Now we can just get the equation of the tangent line. Y minus 0 is equal to our slope, negative 2, times parentheses x minus 2. Use the tangent line to approximate f of 2.2. So we just plug in 2.2. Well, y minus 0 is just 0. Y equals negative 2, plug in the 2.2 for x. That's equal to 2, if the inside here 2.2 minus 2 is 0.2, 0.2 times negative 2 is negative 0.4. So this is your approximation for f of 2.2 using the tangent line at the point x is equal to 2. You can go ahead and start the practice.